Have you ever heard someone say, but it works on my machine? If yes, this video is for you. Today I will show you how Docker help us fix that problem in a very simple way. Hi everyone, I am Anjali Shukla. Welcome to the PeachyCloudSecurity. In this video, I am going to talk about the basics of Docker, like what Docker is, why should we use it, how it is different from virtual machine, its architecture, and the best practices for container security. So let's start with what is Docker. Imagine you have to take lunch to office every day. If you just carry food in your hand, it will split, mix, and things will get messy. So instead of carrying it in hands, you can use a lunch box. The box keeps everything together and isolate it from your laptop. Docker is like a tiffin box, but for applications. It is a tool that helps you to package an applications and everything it needs, like code, libraries, dependencies, and configurations. So this package is called a container. So whether you run it in your laptop or your friend's laptop or a cloud server, the application works same everywhere. So that is why we should use Docker because of its consistency, simplified deployment, resource efficiency, and scalability. Like if I have a 10x load or a 10x traffic, I can run 5 containers instead of 1, and that too behind the load balancers. So how it is different from virtual machines? VM or virtual machines have their full operating system, whereas containers share the host operating system, but processes, files, and resources are isolated using namespaces and C groups. So which results? Containers starts in seconds, use very less RAM, disk, or any other resources, but isolation is slightly different, like slightly weaker than a full virtual machine in case of a containers. So let's talk about its advantages and disadvantages. So advantages like Docker solves a very big problem, and that is a dependency problem. Wherever you want to run your application, whether it is a Windows machine, Mac, or Linux, the application work in same way if it is running on Docker. It is scalable in nature and use a very less resources. What are the disadvantages? That it does not have a GUI support. So you have to use a terminal every time. You have to use a CLI commands. And it is not very good for Windows as compared to Linux. We have a very less isolation in case of a Docker. So it's less secure, though we have solutions or though we have a strategies for the container security that I'll discuss you in a second part. And also it requires a host operating system. So there has to be a host operating system where you will run the Docker. So let's discuss its architecture. So Docker works on a client server architecture. It uses a CLI, that is a command line to give instructions or to reach out to the Docker daemon. Docker daemon is a main process that runs in background. It is a server to whom you give instructions to, and it will take care of everything like building an application, pulling an image from the registry, or running any container. And then third component is we have a Docker registry, similar to a Docker hub where we keep all the images. So we have Docker Hub, which is a public repository, and then we have a AWS ECR, Google Container Repository, or the Artifact Repository. Those are the private one. So let's see a few commands to get familiar with the Docker. So I will just copy these commands here, and I have my code space, GitHub code space environment already set up. So I will run those commands here. So first of all is Docker version. So I'm just checking if Docker is installed in my environment or not. Yes, it is giving me the response. And now let's run a very basic command, which is docker run hello world. So hello world is a name of image that I will run. So if you will notice, it is saying that unable to find this hello world latest image locally. So first of all, Docker will check that whether this image is present in my local or not. If it is not present, it will pull directly from the Docker Hub. So by default, it will pull from the public registry, which is a Docker Hub. So I have successfully run my first container of Hello World image. Next, let's pull the Python image. So earlier, if you'll notice, I did not provide any tag here. So by default, it took the latest tag. Hello world is a name of my image, colon, whatever is mentioned after colon, it is a tag. So if I will not mention any tag, it will pick a latest tag by default. In the second example, I'm specifically providing Python 3.8 slim tag name. So it is pulling that image. So now if you'll notice, here I'm just running a Docker container with the image hello world. Here I'm using a different tags like 3.8-slim. First difference is this. Second, here I'm not only using a run, but I am using -itd along with the Docker run and the bash at the end. So -itd means I is your interactive shell, T is your TTY shell that we get, and D is a daemon or a background mode. Basically, D is a detached or a background mode. So our container is running in a background, and then bash, and I'm attaching a bash shell to it. So let me run a docker ps command to verify it. So if you'll notice, this is my container that is still running. Docker ps is a command to check all the running containers. If I want to see all the containers, whether they are in the running or an exit state, then I will use docker ps -a. So it is giving me two container, one that I initiated 2 minutes ago, which was a hello world container. And as there was no process running, so it automatically exited. And here, as I'm using in a detached mode, so my container is still running. If I want to remove or stop any container, I can just run docker stop command followed by its ID. So I will use docker stop and this particular ID. So now if I will see this container exited, means it has stopped. So there are two options. Either you can directly just run a docker stop and get that container ID. However, if you're writing an automation or working on some automated process, so you can use this filter. So what it will do, it will take this image name and fetch its ID and it will put it here. So automatically, if you wanna use this command to stop a container in any process or in any automation, you can directly use this command. So let me show you this remove a container. Let me copy it and paste it here. So now if I will see, my container is removed. This was this Python 3.8 slim container. So this is removed. So that's how you can write this filter to get the ID. So this was it in this first part, which is the basic of containers and the architecture. Now we'll move to the next section, which is container security overview. So we understood that what is container, why should we use it, and how it is different from virtual machines. And we talked little bit about its architecture as well and got familiar with the basics of containers. Now see, what are the challenges we have with the container security and what are the best practices that we can use to secure our containerized application. So container security means protecting our application and the underlying infrastructure. We have certain challenges with it as well, as we have to take care about the architecture, which is complex in nature. We have our microservices running on containers, which are smaller but have interconnected components. So we have to take care about that. And then we have to take care about the cluster deployment, additional layers we have like our orchestration tool, for example, Kubernetes, our runtime environment, and then different processes as well that are running within that containerized environment. So what are the key areas, if I will add a pointers or if I'll make a note of it, these are the key areas I have that I can take care or that I can protect in my container security. I have images. We can start with the container images. We can create golden images. We can create slim images, and that base image we can use, or base golden image we can use throughout in our production environment. repository, where are we storing our images, whether it is a cloud providers repositories, or these are the Docker hub, or we are maintaining our local repositories. Wherever we are storing it, we have to start with making it private, and only applications, or we can add a access control there. Container runtimes, these are really important, as vulnerability in runtime could lead to a unauthorized access or controls. So we should have to take care about the container runtime. And then the host, underlying host, where our containerized application is present. So we can secure our host, what are the configuration it has, we can regularly patch it, we can look for the weak configurations, outdated systems. So these are the ones that we can check in a container host. And the orchestrator, if we are using tools like Kubernetes, Docker, Swarm, then we can manage its configurations, our bags, its IAM, identity and access management controls, what are the permission different namespaces and different service accounts are having, that also we can check. So what are the 5 key areas? We have images, repositories, runtime, container host, and the orchestrator. So let's discuss a little bit about the challenges in container security. We have a very large attack surface, and if we have infrastructure on the cloud, then all the attack surfaces that are applicable to cloud will also be applicable here as well. Then we have a rapid changes. So we are regularly making changes in our application and updating the images. So there are a frequent update in our applications via CI/CD pipelines. So regularly our environment is changing. And then we have a third-party risk, because container images use the third-party libraries, code, dependencies. So we have to secure those as well. These are some best practices that we can take for container security. We can do a image security, always go for the secure configurations. Whatever best practices defined for host, orchestrator, or runtime, we can do that. And we can limit the container privileges, like not running container with a root user, privileged flag is false. So like this, we can take. And then regularly monitor and update our applications host and images on the CI/CD tools. And then check the supply chain security. We can always verify the integrity of the third-party packages that we are using. We can also create a SBOM for the images, that okay, these are the packages with this version we are using, and we can regularly look for the updates. We can also run tools like Trivy to scan our images and regularly update our packages. So this was it in this video, where we discussed the basics of Docker and the security about it. In the next video, we'll go into the detail and see how we can scan the images, what are the different tools that we can use it. So stay connected for our upcoming videos. Thank you for joining.